Alright, today we're going to look at the hypotenuse leg theorem, the proof of the hypotenuse leg theorem. So we can see that we've got two right triangles, which means we've got hypotenuses here, AC and DF, and these legs AB and DE. So we want to prove that given two right triangles and with congruent hypotenuses and a corresponding congruent leg, that the triangles will be congruent. Now we can see that we can't start out using any other method for congruent triangles we've looked at before. We don't have any side angle side or angle side angle here, and no other way to find anything else, so we're going to have to do a little bit of construction. I'm going to take this, we're going to construct a segment here that is the same length as AB. I'm going to call that DG, and this angle is going to be congruent to angle 1, marked in this the diagram over here. We'll call it angle 2, just for simplicity's sake. So we've got these two congruent angles. We want to make these two angles congruent because then we would have extra information for these triangles we wanted to prove congruent. And we're trying to prove that triangle ABC is congruent to triangle DEF. So we want to show up here. Now, once we connect these dots here, we've got another little triangle, and we're going to connect DG to F. That's all we've added in here. Now, we take a look at right here. We can see DEG is going to be an isosceles triangle. We've got these two sides congruent, so we're going to get 3 and 4 right in here. Now, 3 and 4 we know are going to be congruent. Mark those. Angle 3 congruent to angle 4 by ITT. There are isosceles triangle theorem. Okay, now since we've got that, we can see that angle ABC is going to be congruent to angle DGF. We've got that from this side that was already congruent, this side, this angle 2 and 1, which we constructed congruent, and BG, which we constructed congruent to. So we'll say that triangle ABC congruent to triangle DGF. Now, once we've got those congruent, we try to get a transitive process. We can get this triangle, and this triangle all congruent to each other. So here, and then those two. So we've got these two congruent. That's a good first step. And then we'll take some corresponding parts. We're going to say that angle ABC is congruent to angle DGF, which we happen to know are all going to be right angles. So angle ABC congruent to angle DGF. That's corresponding parts of congruent triangles congruent. Help us out there. Now, once we've got that, we can see that this other one, we've got a right angle, right? So transitively, we can say that angle DEF is congruent to angle DGF. So we've got a DGF, DEF. So those two are congruent to each other, and this angle 6 and 5. Let me get those guys congruent. Angle 6 congruent to angle 5. They're both complements of congruent angles, so they are congruent. Alright. Now, once we've got that down, we can see that these segments over here, GF and EF, are congruent. GF is congruent to EF by CITT. So we're gonna cross there. We got these angles, push it over here, and EF congruent to GF. Okay. Now that we've got that, we can see that these two triangles, triangle DEF is congruent to triangle DGF by side angle side, just like before. We got this side, these two sides, and this angle in between them. We got that there. And then we'll say that triangle DEF is congruent to triangle ABC by the transitive properties. We got this triangle is congruent to, so this big triangle here is congruent to this triangle, and then this one's congruent to this one. So they're all three congruent to each other, which gets us back to what we wanted to originally prove, that ABC is congruent to DEF. Alright, so that's what we've got here for our proof. And we can see that that means that if in two right triangles there exist congruent hypotenuses and congruent legs of triangles, then the triangles are congruent. Alright?